Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Hafiz bin Azman and my metric number is 01DAD20F2035.
Assalamualaikum, my name is Muhammad Ikhwan bin Abdul Halim and my matric number is 01DAD20F2008.
Assalamualaikum and hi, my name is Muhammad Adam bin Muhammad Fakarudin. My matrix number is F2019.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakai bin Zamri. My matric number is 01DAD20F2012.
In this video, we are going to talk about our case study for subject DJA 50082, Vehicle Dynamics. Our lecturer for this subject is Encik Muhammad Zaki bin Zainal. Okay. To answering our questions, we have choose Proton Wajah CPS. The Proton Wajah was a compact sedan car made by Proton, a Malaysian automaker. It was produced from 2000 to 2011. The Wajah was designed to be an affordable and comfortable car with a modern look. It had a spacious interior and could seat up to 5 people. The car came with features like air conditioning, power windows, power steering, central locking, and audio systems. The Wajah CPS had different engine options, including gasoline and compressed natural gas with manual or automatic transmissions. While it was popular for its price and performance, some people criticized its interior quality. In 2011, it was replaced by the Proton Inspira. For question 1, in order to find dynamic load with static condition, we first collected the data about this Proton Wajah CPS, which is the wheelbase is 2.6 meter, the length of the car is 4.47 meter, the width of the car is 1.74 meter, the height of the car is 1.42 meter, the total weight of the car is 11,919.2 Newton, and for the weight front is 7,651.8 Newton, and for the weight rear is 4,757.85 Newton. Other than that, the height of center of gravity is 0.71 meter. To find C, we use the formula, which is weight front equals to weight total C over L. And in order to find C, we use C equals to weight front times L over weight total. And after we made the calculation, we got 1.67 meter for C. Next, to find out B, we just minus the wheelbase with C, which is 2.6 meter minus by 1.67 meter, and we got 0.93 for B. To find dynamic load with moving condition, we use the formula, which is WF equals to W C cos theta minus by H over G AX and minus H sin theta. And after we made our final calculation, we find out that our force for dynamic load with moving condition is 3,300.77 Newton. From our observation, the provided information highlights key aspect of the car's dynamics. The weight distribution indicates a heavier front end, while the presence of a dynamic load during motion emphasizes the additional forces experienced. The acceleration of 12 meter per second contributes to the dynamic load, influencing the overall behavior of the vehicle. The center of gravity height at 0.71 meter affect stability, and the length from the center of gravity to the front and rear wheels play a role in weight transfer during dynamics maneuvers. However, to fully comprehend the vehicle's dynamic, further analysis is necessary, considering specific driving conditions, road surfaces, and comprehensive calculations.
First of all, I would like to say thank you to our team member Muhammad Nur Hafiz for explaining question 1 in detail. And today, I would like to explain more about my question, which is question 2A and 2B. So, we are required to compare which we want to use the the original size wheel or the modified size rim. So, the original size rim for this Proton Wajah CPS 2008 is 15 inch. So, we would like to compare this 15 inch rim to 16 inch rims to see whether the traction force and the traction limits is there any difference at all. So, Proton Wajah CPS 2008 has a max engine torque of 148 Nm, max engine power of 109 horsepower. The rim radius is 15 inch, and then we convert it into meter. We got 0.381 meter. The final drive ratio for the Proton Wajah CPS 2008 is 4.33. The mechanical efficiency is 75%, and the gear ratio is, for the first gear is 3.58, for the second gear is 1.95, for the third gear is 1.34, for the fourth gear is 0.98, and last but not least is the fifth gear 0.8. Next, we would like to start with the traction force for the 15 inch rim. So for this question, we use the traction force formula, which is TE times NTF times coefficient of friction TF over radius. So for the first gear, the calculation that we got is the result that we got is 4528.04 Newton. For the second gear is 2466.39 Newton. For the third gear is 1694.85 Newton. And for the fourth gear is 1239.52 Newton. And for the fifth gear is 1011.85 Newton. Next is the traction limit for the rims 15 inch. So for this one, we use the Fx max formula, which is Newton weight Fs over 1 plus height over L over Newt. So from this one, we have to know the weight front of the vehicle, the CG height of the vehicle, the coefficient of friction of the vehicle, and the wheelbase of the vehicle. So we insert the information that we got, which is the weight front of the car is 7651.8 Newton. The CG height is 0.71 meter. The coefficient of friction is 0.62, and the wheelbase is 2.6. So from the calculation, we got that the traction limit for Wajah 2008 is 4057.20 Newton, which we use the 15 inch wheel. And next is the traction force for 16 inch rim. So for this one, our objective here is to do a comparison between a 15 inch rim and 16 inch rim. So we use the same formula, which is the traction force formula, and we insert the information. But what we change here is the radius of the rim, which from the 15 inch rim we got 0.38 if we convert to meter, but for 16 inch rim we convert it and we got 0.4. So from the calculation, for the first gear we got 4301.64 Newton. For the second gear is 2343.07 Newton. For the third gear is 1610.11 Newton, and the fourth gear 1177.54 Newton, and last but not least is the fifth gear. We got 961.26. So from this we can see that the traction force of 15-inch rim and 16-inch rim, there are slightly difference between them, which we can see that the 16-inch rim has slightly lower calculation result than 15-inch rim. Last but not least is the traction limit for the 16-inch rim. So what we change from the 15-inch rim is not much. We just change the weight front and the CG height, because based on our assumption, by changing the rim size, it gives more weight and more height. So the weight front we change to 7656.7 Newton, and the CG height becomes 0.73 meter. The increase is only 0.02 meter only. So we put this information into the same formula, and we got the answer 4043.31 Newton, which is much lower, which is slightly lower than 15-inch rim. So from this calculation, I think our group agree to choose the by comparing the projection force and limits between 15-inch rims and 16-inch rims. The difference is relatively small. The 15-inch rims show slightly higher traction force but similar traction limits. When deciding whether to use the same size or different size tire, factors beyond traction should be considered, such as ride comfort, handling, and compatibility with the vehicle systems. Tire size alone may not be the sole determinant of traction, as other factors like track design and road conditions also play a role. Therefore, a comprehensive analysis considering these factors is needed for an informed decision on tire size. So based on our calculation, we have discussed and we choose the 16-inch rim for our vehicle. Next, we will move on to question 2b, which is braking hypothesis. After we did the calculation of traction limit and traction force for the 15-inch rim and 16-inch rims, we will move on to the braking hypothesis, because we will also do a comparison between this one. So in this question, we will search for the stopping distance, braking force, and power output for both rims. So for the 15-inch rim, we use the formula of stopping distance, which is velocity square over 2 coefficient of friction times gravity, which will be result in we use the 100 km per hour as our landmark, so we convert it into the meter per second, and we got 27.78 meter per second square over 2 times 0.62 times 9.81, and the answer we got for the 15-inch rim is 63.44. And we use the same stopping distance for the 16-inch rim, because there are no information that we change for stopping distance. But for the next part is the braking force. There are slightly difference between the 16-inch and the 15-inch rim, because we use the formula of mass times velocity square over 2 times stopping distance, which is the mass is difference here, because as based on our assumption, if we change the size of the rims, they are slightly lower or higher weight of the vehicle. So from this one, the 15-inch rim, the weight of the vehicle is, the mass of the vehicle is 1215 kg, and for the 16-inch rim, the weight of the vehicle become 1216 kg, which is only 1 kg difference. So for the calculation, For the 15-inch rim, we got the braking force 7,390 newtons, and for the 16-inch rim, we got 7,396 newton, which is only 6. The difference is only 6, but we can see the slightly difference between the 15-inch rim and the 16-inch rim. So, and last but not least is the power output. This one also has a slightly difference because the braking force, which is F times V, where we search for the braking force. The braking force for the 15-inch and the 16-inch is different. So the power output that we got from the 15-inch rim is 205,294 joules, and for the 16-inch rims is 205,460 joules. Based on the provided information regarding braking hypothesis for 15-inch rims and 16-inch rims, we can make the following short discussion, which is the stopping time is the same for both rim size, with a distance of 63.44 meters required to come to a complete stop. The braking force is slightly higher for the 16-inch rims compared to the 15-inch rims, with 7,396 Newton versus 7,390 Newton, which is respectively very slightly. However, the power required for braking is significantly higher for the 15-inch rims at 2053 kJ, 205.3 kJ compared to 205.5 kJ for the 16-inch rims. This result suggests that while the stopping distance and braking force are comparable between the two rim size, the 15-inch rims require significantly more power for braking. This could indicate that the braking system on the vehicle with 15-inch rims is less efficient, resulting in higher energy consumption during braking. Further analysis and consideration of other factors such as the vehicle weight, tire characteristics, and braking system design will be necessary to fully understand the implication of this result. So from the calculation that we got from the question 2A and 2B, we can justify that we can justify the reason why we choose the 16-inch rims for our vehicle, because it costs less power to stop the car.
So today I will be presenting to you about drag components. Drag coefficient component for body consists of forebody, afterbody, underbody, screen friction. Drag coefficient component for internal consists of cooling system, and drag coefficient component for protuberance consists of wheel and wheel, drip rails, window recesses, external mirror. So next we will be moving on to question 3. After a few discussions, we decide to add skirting, spoiler, and bigger the rim size to maximize the downforce to get the better airflow for the car. This is because to achieve drag coefficient component for body, we need to change a few things on underbody, afterbody, and forebody. So I'm choosing skirting because it can improve the airflow. Other than that, we change the rim size from 13 inch to 16 inch.
Okay, I will to explain about my point is for question 4. Okay, for your information, you can see for our slide is I have put the information about natural frequency and the damping ratio. Okay, for the natural frequency we have a formula 0.159 and square root RR, right, over mass. Okay, and then you can see the formula is, and then I put the information for that formula After that, we get the final answer is 35.5555 Hz. And for the next formula is damping ratio. For the before I move to damping ratio, for natural frequency, for the front and rear have a same answer. And then for the damping ratio, we have two answer for front and rear. For the front and rear have a same formula, that is CS divided by square root 4 KSM for mass. Okay. For the CS, for the front, we put 5000 divided by square root 4 multiply 1000 and multiply for 730 for the mass. So total for front, we get damping ratio 0.3, and after that we have a damping ratio for rear, that is 5000 divided by square root 4 multiply 1000 and then multiply 485, and damping ratio for rear we get 0.36. And after that, I have a question about does the tire is comfort for during the driving. So the tire does affect the comfort of passenger in a car. Larger tires with a larger contact area provide better cushioning and absorb road bumps more effectively, resulting in a smooth ride. The increased sidewall height of larger tires allow for more flex and shock absorption. So for the conclusion about the tire is very comfort for the passenger and the driver for using this ratio to usually driving on the road. Then the given information reveals that the vehicle suspension system has a natural frequency of 35.55 Hz with a damping ratio for front 0.3 for the front tire and 0.336 for the rear tire. This value suggests a balance between handling and comfort. The higher natural frequency indicates a potential sporty and responsive handling, while the damping ratio indicates a level of vibration damping for improved ride comfort. Then, however, it's important to consider that these values alone do not provide a complete assessment of the overall ride quality. Okay, this is overall what I have information about my topic and my point. So I hope this explanation is enough for my answer. So then, thank you for listening my question. Assalamualaikum.